Hello, this is FlippedHarber for Algebra 2. In this video we'll be talking about section 4.4, Determinants in Cramer's rule. Now our objectives for this lesson are to find the determinants of 2x2 and 3x3 matrices. We also want to use Cramer's rule to solve systems of linear equations. Now a determinant is a plain old number that we get from a matrix. It's now no longer a matrix anymore. It's the difference for a 2x2 matrix. It's the difference of the cross product of a matrix. And determinants can only exist for square matrices. So we're going to be looking at how to find the determinant for a 2x2 and a 3x3. To ask what's the determinant of a 2x3 or a 1x4 doesn't make sense. Okay, so for a 2x2 matrix, all you do is take what's referred to as the primary diagonal, A times D, minus the other diagonal, B times C. Now, we will use the determinant to find the inverse of a matrix. That's going to be in a couple sections or so. But we also use the determinant to solve system of equations, and that's exactly what we're going to do today with Cramer's rule. So let's start by just looking at some examples. Let's find the determinant of this 2x2 matrix. Now we take the 6 and the 3 and multiply, minus 5 times 8. You always subtract the second diagonal. So we have 18 minus 40. So the determinant of this 2x2 matrix is negative 22. Now the way that we're going to use these determinants in order to solve a system of equations is to look at our system of equations as matrices. Okay. Now notice that these equations, are in standard form. Now the second part isn't necessary, but it's nice. It's nice that we have whole number coefficients. If we have a fraction, it's totally possible to do, but you might want to multiply by something to get rid of that fraction. But it's not necessary. I've got everything in standard form. That means that it's x plus or minus y equals a number. And in this case, I've got whole numbers, which is nice but not necessary. Now what I'm going to do is make a matrix from the coefficients on the left side of the equation. So in front of the x is what's referred to as an understood 1. So that's my first entry in my matrix. Then I have minus x, so that means that it's minus 1x. So negative 1 becomes my second entry. Now from my second equation, I get a coefficient of 2 in front of the x, and again a negative 1 in front of the y. So we're actually going to use this matrix in order to solve this system of equations. And that's this process called Cramer's rule. Now, we just talked about determinants, so obviously we're going to use them in Cramer's rule. And the first thing I want to do is find the determinant of this new matrix I just made. This matrix, by the way, is referred to as the coefficient matrix. So we know how to find the the determinant of this matrix. We multiply the 1 times the negative 1 minus negative 1 times 2. So in this one, we get a determinant of 1. Now we call that determinant in Cramer's rule D, and we're going to use it a couple different times. That's why we bother to give it a special name, D. Now, in order to use Cramer's rule, what we need to do is take D, make it the bottom of a fraction, so we're going to divide by D, and I've set up some new determinants to find. Now, the way that these two new determinants were created is the y column was left alone in this matrix, but the x column was replaced with the two answers from my system of equations. So you'll see that the 3, negative 1 replaced this x column. Well, why did I replace the x column? Well, I did it because I'm solving for x here. So I find this new determinant and I divide by d. Now we know that d is 1 for us. So I'm going to take this new determinant and divide by 1. So 3 times negative 1 minus negative 1 times 1, well, that's negative 4. Divide it by d, which is 1, and I get negative 4. So x equals negative 4. Over here, solving for the y, we leave the x column alone. So you see that the x column has not been changed. It's the y column this time that's been changed. And how have we changed it? We've put the answers from the equation in for that y column. So you see that those answers have replaced the y column this time. So when I solve for x, I replace the x column. When I solve for y, I replace the y column. Again, I find this determinant, which is -7, and I divide by d, which in our case is 1. So we get y equals -7. Now, if I wanted to check this, I could just plug them into my system. -4 minus a -7, well, that equals 3. So this is a true statement. 2 times -4 minus -7, that's -8 plus 7, which is -1, and that's a true statement. So hey, Cramer's rule found the answer for me. So yes, -4, -7 is the solution. And this is actually how I should report out my solution again. Remember, whenever you're reporting your answer for a system of equations, it should be an ordered pair for a system of 2 variables, or an ordered triple for a system with 3 variables. Well, now that I've mentioned that, a system of 3 variables, we need to go ahead and talk about how to find the determinant of bigger matrices. So here's a big old fat 3 by 3 matrix, and we're going to need to find the determinant of it. And here we see another notation. Instead of the straight bars, we can just write DET, it's short for determinant obviously, in front of the matrix, and it says we want to find the determinant of this. So this is a trick that works for 3 by 3 matrices. Don't try to use this on 2 by 2. Don't try to use it on anything else. This is a trick that works for 3 by 3 matrices. So you'll see that I have the matrix here, and after the matrix I've piled on the first 2 columns again. So this is just a trick. This is a method that works for 3 by 3 matrices. Now what I'm going to do is multiply diagonally, going from upper left to lower right, and I multiply 3 times with 3 different diagonals, and then I subtract 3 more diagonals, in this case these red ones. So we see A1 times B2 times C3 right here, plus B1 times C2 times A3, plus C1 times A2 times B3. Now we switch directions and we switch signs. So now it's minus C1 times B2 times A3 minus A1 C2 B3 minus B1 A2 C3. So this is our method for finding the determinant of 3 by 3 matrices. You are not going to have to find the determinant for bigger matrices than this. You just don't need to worry about it. It's actually a fairly hardcore thing for us to do. So we're going to stick with the 2 easy types of matrices, the 2 by 2s and the 3 by 3s. And this is how we find the determinant of a 3 by 3. Okay, so we can apply Cramer's rule to a system of 3 variables as well. We're going to have to find our D again. We're going to have to find the determinant of the coefficient matrix. It's going to be a lot bigger than it was last time. But let's go ahead and find the determinant of this. Now I haven't spelled out the method. You should be able to do this on your paper. Remember, you pile on the last 2 columns and you do diagonals this way and then subtract diagonals going the other way. So we end up with 36 plus 16 plus 0 minus 36 minus 0 minus 36. So our determinant, our D, is -20. Now I'm going to need to set up 3 additional determinants. I'm going to replace the P column with these answers, and that's how I'm going to solve for P. Then I'm going to replace the C column, this 4, 1, 0, with my answers, and that's going to find my C values. Then I'll replace the F column with my answers. So that's going to look something like this. We replace the P column with the answers. We're going to divide by -20 after we get this determinant, and then that's going to find the value for P. Here we see the new determinant we need to find for C, and here we see the new determinant for F. So when we go through the process, we end up with -5400 on the top in our P work, and then we have -7200 for our next determinant, and then -2400 for our third determinant. When we divide by that -20, we find out that P equals 270, C equals 360, and F equals 120. Okay, so I know that's a lot to chew on, but the best way to start to take a bite out of this is to actually get to work on some of your own. So I'll see you in class, and I'll see you online.